Good afternoon and welcome to today's Hydraulics and Pneumatics webcast. Our topic today is improve the performance and extend the life of your fluid power cylinders in your most demanding applications. It's sponsored by Peninsular Cylinder. I'm Alan Hitchcock, editor of Hydraulics and Pneumatics, which is part of Design Engineering Informa's Design and Engineering Sourcing Group. To begin, let me explain how you can participate in today's presentation. First of all, if you have any technical difficulties during today's session, simply hit the F5 key to refresh your webcast console. If you need assistance solving common issues, please click on the yellow Help icon below the slides. In addition, we welcome your questions during today's event. We will answer as many questions as possible during the Q&A session that will follow the main presentation, but please feel free to send in your questions at any time. To do so, simply type your questions into the question window on the side of your screen and hit the Submit button. Also, please be aware that today's session is being recorded and will be available on the Hydraulics and Pneumatics website within the next week. You'll be notified by email when the archive is available. Now, let's meet our speaker. Bill Tyler started his career in 1973 as a machine operator and shortly thereafter completed his training to become a journeyman machinist. Simultaneously, he studied industrial engineering at Purdue University and received his Bachelor of Science in Business degree from St. Joseph's College. Bill's organizational mission always has been to foster a culture of world-class customer satisfaction with engineered value. Now let me turn things over to our presenter. Bill, the floor is yours.
Thank you for the warm introduction. Welcome to today's webinar on suggestions to improve performance and extend service life for hydraulic or pneumatic cylinders in demanding applications. Peninsular will be taking an in-depth look at value-added cylinder features and where they might be best applied. This session has been pre-recorded. However, I will be available after the presentation for a question and answer period. Please type your questions in the comment section. I would like to thank everyone for attending today's session. Hydraulic and pneumatic cylinders are one of the most basic fluid power components in a motion-controlled system, and due to the versatility of the many options of configurations, they are used in the simplest to the most demanding applications imaginable. The environment in steel processing, foundry equipment, and the lumber and wood industry, to name a few, are especially demanding considering the temperature ranges, airborne particles, loads, and operating pressures which are inherent to the applications required to perform the work. Today, we will take a closer look at some of the variables which, if not addressed properly, can result in premature or catastrophic failure of the cylinder. Let us first look at choosing the right mount for the application. Trouble-free use of fluid power cylinders depends in large part on properly mounting the cylinder for the particular application. Cylinder mounting styles generally provide straight line force transfer with fixed mounts that absorb force on the center line of the cylinder, straight line force transfer with fixed mounts that do not absorb force on the center line of the cylinder, and pivot force transfer with pivot mounts that absorb force on the center line of the cylinder and allow the cylinder to change alignment in one place. Cylinders with fixed mounts that absorb the force on the center line of the cylinder are considered the best for straight line force transfer. Tie rods extended, flange, or centerline lug mounts are symmetrical and allow the thrust or tension forces of the piston rod to be distributed uniformly about the cylinder center line. Side-mounted cylinders do not absorb force along their center lines. These mounting styles have lugs on the end closures, and one style has side-tapped holes for flush mounting. The plane of their mounting surface is not through the center line of the cylinder. For this reason, side-mounted cylinders produce a torque moment as the cylinder moves the load. This moment tends to rotate the cylinder about its mounting bouts. If the cylinder is not well guided, side loads will be applied to the rod gland and piston bearings. For heavy loads or shock conditions, side-mounted cylinders should be held in place with a key or pins to prevent shifting. A shear key consisting of a plate extending from the side of the cylinder can be supplied with most cylinders. It should be placed at the proper end to absorb the major loading at the end with the load in tension with the cap and with the thrust load. Cylinders with pivot mounts that absorb force along the center line should be used when the actuated load travels through an arc. There are two ways to mount a cylinder so it will pivot during the work cycle: clevis mounts or trunnion mounts. Pivot mount cylinders are available with fixed cap clevis, detachable cap clevis, cap spherical bearing, and head cap and intermediate fixed trunnion. Pivot mount cylinders can be used in tension or thrust applications at full rated pressure, except that long stroke cylinders in thrust are limited by piston rod column strength. On large stroke thrust applications, it may be necessary to use a larger diameter piston rod to prevent buckling or use a stop tube to minimize cylinder side loading in its extended position. In a real world, all cylinder applications begin by choosing the correct mount. That is certainly the first place to start, and if any conditions like side load, contamination, and excessive wear is anticipated, please understand that there are a number of options available to address potential issues. For example, 1. Piston wear bands. 2. Rod bearing wear bands or liners. 3. Chrome bore tube. 4. Increased bearing lengths on the piston and or rod bearing. 5. Stop tubes. 6. Metallic rod scrapers. 7. Linear alignment couplers. And 8. Bronze-clad piston overlay. We will cover a few of them in the next section of our presentation. One of the most popular options for excessive side load and high cycle rates is a wear band incorporated into the bearing and or piston. On pistons, we recommend a wear band which offers the following features: ultra precision, turn to plus or minus 1/1000th of an inch, eliminate metal-to-metal contact and the consequent galling and scoring of cylinder bores and rods, readily ingest harmful metal flakes, burrs, and small chips, will not generate contamination as is common with metallic guide bands, compatible with all common hydraulic oils, water emulsions, water glycol, and phosphate ester fluids, as well as many others, will operate at temperatures to 350 degrees Fahrenheit, high compression strength, self-lubricating, extra long wearing, and low coefficient of friction. Piston wear bands are available in a bronze-filled Teflon wear strip, special formulated nylon, as well as other phenolic materials designed and suited for specific applications. To continue in this vein, preparing a rod bearing or cartridge in the same fashion offers the same advantages as mentioned earlier. Eliminate metal-to-metal contact and the consequent galling and scoring of cylinder bores and rods. Readily ingest harmful metal flakes, burrs, and small chips. Will not generate contamination as is common with metallic guide bands. Compatible with all common hydraulic oils, water emulsions, water glycol, and phosphate ester fluids, as well as many others. Will operate at temperatures to 350 degrees Fahrenheit. High compression strength, self-lubricating, extra long wearing, and low coefficient of friction. Rod bearing options include DU liners, wear bands, polylube bearings, and Duralon bearings. In most cases, these features can be incorporated into components without changing the NFPA standard envelope dimensions of the cylinder. An alternate option to side load or misalignment could be a linear alignment coupler. Self-aligning rod couplers prevents binding and erratic movement caused by misalignment, permits greater tolerance between cylinder center line and mating member, reduces rod seal and bearing wear, and equally well suited for push or pull application. When addressing contaminations or caustic environments, a value-added option that can be overlooked is a metallic rod scraper to replace standard nitrile or urethane rod wipers. Wipers and scrapers are an integral part of the bearing design to keep contamination from entering the internal portion of the cylinder. Metallic rod scrapers are the most aggressive design to control contamination entering into the cylinder and ultimately the hydraulic or pneumatic system. Metallic scrapers incorporate a stainless steel string that provides maximum scraping effectiveness encased in an elastomer allowing radial movement without binding or galling. An alternate option would be what Peninsular calls the shed seal. The shed seal is designed to prevent the ingress of foreign particles and moisture into the cylinder. The profile has been specially developed for harsh environments. The unique feature is the flap on the wiping lip, which covers the gland housing, preventing the water or slurry trap so common with conventional wipers and thus ingress of contamination around the outside of the wiper. The internal ribs on the inside diameter prevent the possibility of pressure trapping between the gland seal and the wiper and ensure correct support and guidance of the wiping lip, even in cases of high eccentricity, as can occur between the outer stage gland and the inner cylinder of a roof support leg. Rod boots are also a viable option to minimize contaminants affecting the performance of the cylinder and system. The boot, which can be made of various materials depending on the environment, works as a shroud or cover protecting the rod from the invasive environment of which the cylinder is subject to. For a more comprehensive look at options available, please visit our website at www.peninsularcylinders.com. Highlight the Tips and Tools section on the menu and hit Technical Support. It is there that you will find our application data guide. For your convenience, we also have an online application data sheet under the Tips and Tools section, which will enable you to communicate your application and environment requirements electronically. This tool also allows you to attach drawings and/or sketches. Thank you for your attention. Please feel free to type in any questions you may have.
Okay, thanks very much, Bill. A few of you have already submitted questions, so we're going to jump right in. If you'd like to submit a question, type your question into the question window on the side of your screen and hit the Submit button. While we are answering your questions, please complete the feedback form, which is located at the bottom of your screen. Our first question says, what seals do you use for high temperature applications? Bill, do you have an answer for us there?
Yeah, depending on the temperature range, Viton is the common go-to up to 400 degrees, and then beyond that you go to Teflon up to about 600 degrees. Beyond 600 degrees, we would have to do some research, but I'm sure there's some seals out there for 1,000 degree temperatures.
Okay, so the seals are, because most of those temperatures are higher than what the hydraulic fluid would be, so it's mainly selected based on the ambient temperature or around the cylinder. Is that right?
That's correct. That's correct, yes.
Okay, next question. How do you know what bearing liners should be used?
Once again, and I don't want to repeat myself over and over again, but depending on the application, excuse me, you know, if you anticipate a side load and you know you're going to get some extra, you know, bearing wear, there are different liners that can be used. There's a calculation on the pounds per square inch load on the bearing itself. And, you know, we would try to do the calculations and determine what would be the best liner. You know, they start out just like best, better, and best, or I'm sorry, good, better, and best, where, you know, you can have an application with just minimal side load, or you can go to a DU liner as opposed to a Polylube or a Duralon.
Okay, very good. Also part of this whole system of supporting the rod is the metallic scraper that you mentioned. What metals are these scrapers typically made of? A
hardened bronze material or a stainless steel material. and then they're energized. Some of them are energized underneath to, with a rubber seal for sealing, as well as to energize the scraper onto the rod.
Okay. Then online, you have. I know you and other manufacturers have an online data sheet where it prompts you for information about, general information about the application and the size and configuration of cylinder you need. Once somebody submit that, what happens to that information?
Well, we get the application request from the customer, and it goes to our customer service department. We then contact our local regional sales manager and tell them there was an inquiry, so he can go reach out to the customer and let them know that we're working on it. It gets sent over to engineering for an evaluation. In most cases, the application data sheet's really comprehensive. So a lot of the questions that we may have are answered in that electronic form. And what we will do then is come up with recommendations on a cylinder. It all depends. You can submit drawings, you can submit application data, you can submit sizing charts, and we'll look at all that and we'll make a recommendation on what the customer is looking for. We would then go back to the regional sales manager, prepare a quotation, and possibly a descriptive, either a drawing or a descriptive note of what we would be proposing, and that would go back to the customer through the regional sales manager and a local distributor.
Okay, thanks. We have another question here, but before we get to that, I have a question. The question
Yes, sir.
is, the question that's submitted is, what's the best swivel angle of the bearing for easy alignment? But let's go ahead and answer that one, then I'll close mine. What's the best swivel angle for easy alignment of the bearing?
Are you talking about the rod bearing or the spherical bearing that would be on a pivot mount?
That I assume it's the spherical bearing at the rod end.
Okay, well, depending on the size, it can be up to 1.5 degrees. But there's some where we can get a bigger angle on that too. Depends on the size of the pins. And again, if anyone has questions on that, we can do an application sheet and get a clear answer to whatever the size cylinder it is.
All right, then my question is the rod alignment coupler that you showed in the video, in the presentation, that rod alignment coupler, is that the same? Is that basically a spherical rod end bearing, or is it something different?
The linear alignment coupler? Yeah. No, that's something different. It rotates 360 degrees at about a 30 thousandths gap between, one point or another, or actually 15 thousandths. A total 30 thousandths movement, but 15 thousandths on the side. And if there is some side load or deflection in the rod, that linear alignment coupler will help offset some of that.
Right, or any misalignment at all.
Yep.
Oh, okay, good. Because I thought it was some marketing ploy thing to where it's a fancy name for a spherical rod end bearing. But I'm glad I asked. It is different then. Next question. This is a good one because it's a topic that we frequently write about in hydraulics and pneumatics. Does filtration of the fluid affect the life of the cylinder?
Oh, most certainly. Contaminated fluid can, you can trap contaminants between the piston seal and the the OD of the tube, and it would start to, disintegrate the seal itself. I don't know, even a cast steel ring would trap the contaminant between the tube and the cast steel ring and start scoring marks on the cylinder. So, it's the best thing to do is have, 5 micron at best in the system, a 5 micron filtration unit.
Okay. My next question, the next question that's posed, it's a little off topic maybe, but it still has with the contamination. How should you keep contamination out of hydraulic fluid, and what can be done to remove contamination in the fluid already?
Well, starting off with a clean system, to a standard, and there is an ISO cleanliness standard we can share with people that's specifically relative to hydraulic cylinders and the systems they're in. So depending on what the other componentry is, say a piston pump or any of the control valving that could be in there, you might want to establish that for your individual application, and we can help with that too. Normally, some preventative maintenance on the equipment, such as kidney loop filtration at specific intervals and fluid testing, third-party testing. We like to send it to any of the testing labs, and it's very inexpensive to make sure that once you've done your preventive maintenance, that you record what the cleanliness of the cylinder is and monitor the effects of your PM program on a hydraulic system. But definitely the life of the cylinder, the life of the specific hydraulic components is relative to the cleanliness of the oil. So again, the filtration, the strainer in the tank, the methods that you use to keep it clean, like kidney loop filtration, and then testing of the fluid for the contamination levels to an ISO standard that you've established is the best thing you can do.
Okay, excellent. And the questions are coming in faster than we can answer, so, which is good, because you allow plenty of time for that. Our next question is asking about any recommendations on periodic maintenance for repair or replacement of cylinders or components, and how is that affected by the environment?
Well, every application is different, and Peninsular Cylinders, as well as other manufacturers, deal in just about every industry that uses cylinders. So it depends on the application again, but once something's established on the life of the cylinder within the application, there could be specific programs for inspecting the cylinders or repairing or replacing them. And usually in an application there could be a failure mode like the rod end bearing or the piston seal, so you can have keep stocks of the repair kits on hand so the company's maintenance employees can learn how to repair the cylinders or send them back to Peninsula to our repair division for rehabilitation.
And if I could add to that, there's, in a cylinder failure, if you're looking at, preventive maintenance, there's two areas that you would want to watch out for, and that would be piston bypass, or that would be rod seal leakage. In the event that you have, an aggressive environment or just extra wear, if you start seeing, your load, you got to crank up the pressure to move a load, you may be getting a little bit of piston bypass, or if you start seeing a thicker ring around your rod wiper on the piston rod, you may start seeing some, side load or just rod wiper, rod seal leakage. Those are indications that you probably, if you want to do some preventive maintenance before it just catastrophically fails, that I believe that would be, an answer to that question.
Okay. Next question is, and this is actually my question. With the kind of hands on this. When you have cylinders, sometimes, I imagine it's pretty rare that they get completely destroyed, where there's nothing salvageable. So some of the more serious damage could be, for example, when there's a dent placed in the cylinder barrel or the tube, or if the rod itself gets bent. How do you determine when you have to provide a new cylinder and when one is beyond repair? What would be some of the conditions where a cylinder, you say, this thing's beyond repair and it's going to be more cost effective to make a new one?
Well, if the tube is bent and everything else seems to be intact, we would just supply a new tube. If the rod was bent, we would supply a new rod. If the tube and the rod is bent and the pistons wore and the rod bearings wore, what we do, because we also repair cylinders, our businesses, so we're a cylinder manufacturer, but we have a repair business unit within our company. And what we normally do is we look at the cylinders, and if it's beyond economical repair, we will quote a brand new like and form, fit, and function type cylinder. Typically, if you start going over 50 to 60% of a new cost of a cylinder, it makes sense to buy a new cylinder. But anything under 60%, you can repair it. And it just depends on the damage of the cylinder. I mean, if you've got a bent tube, when you've got a stroke, it's going to bind up. If you got a bent rod, it's going to bind up, and it just won't stroke properly. So we would know that.
And it also depends on the size of the cylinder. Obviously, the bigger the cylinder, the more cost-effective it might be to repair the surfaces, regrinding, rechroming, and there's various coatings for the piston rods too. But in the end, it just depends on the size. Like a very small cylinder could be too costly just even replacing the bearing, piston, and the seals on it, and you're better off buying a new cylinder. But as the cylinders get larger and longer, there's things that can be done to keep the cost down on the repair.
Okay. Thank you. The next question is, say somebody's starting to specify a cylinder, and they may decide they want to start with an NFPA standard cylinder. Where would somebody go to find what those standards are for NFPA hydraulic cylinders?
Well, most major cylinder manufacturers publish and sell NFPA standards in their dimensions and their dimensional catalogs. I would suggest if that's not good enough, you go right to the National Fluid Power Association and request the ISO and international standards for cylinder design.
Okay, so many of these standards, which the NFPA standards, are now actually also covered or instead covered by ISO standards.
Right. Well, I'll clarify that a little bit. And a company's catalog, dimensional catalogs, and the online geometry configurators we are certifying that they meet NFPA dimensions. And then when you go to the NFPA, you can purchase the NFPA standards, but you have to go to the ISO, International Standard Organization, to purchase any ISO standards.
Oh, okay. Okay, got it. Next question we've talked about a little bit, but not this specifically. Would the self-aligning rod coupler assist with reducing or eliminating side loading?
To a degree. Again, it all depends, how much side load is on the cylinder. There are, at the beginning of the presentation, we talked about, selecting the correct mount, and there's the rigid mounts, and then there's some that are more forgiving, like a trunnion mount or a clevis mount. And if you've got the clevis mount in there and you use a style 9, or the spooled rod end, if you will, is one option to give some relief at the end of the rod, as is a spherical rod eye or rod clevis, as is a linear alignment coupler. Eliminate, I don't know.
If the side load is specifically from misalignment, then within the range of the alignment coupler's forgiveness, if you will, it would take up that side load. But if it was literally a 200-pound load, at a 90-degree angle to the extension of the cylinder, no, it wouldn't help with that.
Okay.
Next question. To the extent of misalignment.
Okay. Next question is near and dear to my heart, because I remember reading an article we wrote in H&P discussing this very issue, and I have been unable to find it. So this gives me greater incentive to look for it. The question is, the viewer says, our applications typically have very long hydraulic lines from the hydraulic power unit to the cylinder. Fluid in the cylinder may never get back to the hydraulic power unit. So it's a type of thing to where there's more fluid in the lines for feeding the cylinder and return line. There's more fluid in that than there is in the cylinder. So each time it cycles, the fluid goes into the cylinder, comes out of the cylinder, and it never gets a chance to work its way back to the power unit, so it can't get filtered. So do you have any recommendation on that?
Well, I'm going to let Bud answer that, but there's another problem associated with that too, is that depending on if it's a short cycle cylinder, you're going to generate a lot of heat.
That's what he's saying, yeah.
And the heat, and you're not filtering the oil, so yeah. So go ahead.
No. Well, interesting, and we did a big job for a company on a test platform for turbine blades. And they were, obviously, was a high-frequency accelerated test, and they had that same problem. And there's a couple things you can do. One is cast iron piston rings that have a little bit of blow-by design, and allows the oil to continually move through at a slower rate, but over time to keep the oil exchanging. There could be other situations if you get creative with the circuitry where you add a periodic purge in the logic, where during some part of the cycle when it changes to a different aspect of the operation of the equipment, that it would allow the fluid to bypass in that area. But that could be costly and expensive. I'm going to kind of stick with the cast iron piston rings, and we applied that successfully at a very large multinational company where it was a specific issue.
Okay. What ISO, the next question is, what ISO rating do you I assume it's for the fluid cleanliness. What ISO rating do you recommend for fluid cleanliness in the cylinder? You've already mentioned that dirty fluid is going to reduce the life of the cylinder, especially the seals and maybe some of the bearings. So is there an ISO rating recommended for certain cylinders?
Well, that's a great question, and it's something that confronts us regularly because every application may be different with different hydraulic components. And for instance, for our test stand where we're testing the cylinders, there's a specific ISO standard for that, whereas there's a slightly different one for piston pumps or for cylinders in operation. So we maintain a very stringent number in the ISO standards. It's a three-part number that relates to the size of the contaminants and how many of the particular particulate per millions that it's allowed. So it's a basic chart that I think we should publish on our website and also in our literature. So really the answer is depends on what are the components in the hydraulic circuit, and there's different standards for testing and for cylinders, different yet for cylinders, and different if you have a piston pump per se in a circuit also.
Okay, very good. Now, another question, this is one that I was going to have too, was it has to do with rod coatings. And what type of coatings do you recommend for rod, piston, and cylinder bore? And I'd like to interject that, chromium is one of these, it's a controversial topic because it's the manufacturing of chromium is, it's considered a toxic substance. But then when you talk to those producers, they go to great lengths to make sure that any contamination is dealt with. So so chromium still seems, from my view, and that's what I would like to get your opinion. Chromium still seems to be a very good coating for piston rods. And so if you have any recommendation, if you're seeing alternatives that are becoming more favorable.
Okay, yes, great question, and all of our different customers and their applications, we're getting quite a list of different coatings that we're using on the rods and the tube and the bearing, what have you. Chrome is still the go-to. The manufacturers of the tube and the rods have perfected their processes with any of the substrate coatings and finishings and thicknesses. And there's a sundry of chrome platers that have their tweaks on it and their thicknesses. For instance, in the foundries, you might have 1,000 chrome per side, and that's got to be done by the right plater because, otherwise you'll get flaking or cracking and peeling of that plating. Second to that, we've been using with good success the nitrocarburizing process. There are some manufacturers of it, but we also make custom cylinders where each individual rod or tube is nitrocarburized. And what it is it gives a very thin skin of hardness within the dimension of the piston rod itself, where some of the carbon was precipitated to the surface through the heat treating process. And it also has been proven to be better corrosion resistance than chrome in these outside applications. And we've had some good success in the railroad industry and other areas like that. We also have worked in some areas with some spray metallizing and some proprietary formulations and up to 90 Rockwell on the piston rods themselves, and then we regrind them afterwards, and especially in the repair area. So there's some much harder spray metallized substrates that we're able to get on there. And lastly, there's been another standby on bearings and pistons that we do quite a bit of, and it's the bronze cladding or the Amco brass cladding that gives a little bit harder and better wear surface. And sometimes a combination of some of the above too leads to longer life, and typically double and triple the life of just the chrome plating.
Okay, excellent. Next question, and this one I'm going to interject a little bit. We've been talking pretty much about hydraulic cylinders, but pneumatic cylinders, I know Peninsula is also well known for making pneumatic cylinders. The question has to do with, so I'd like them to be two different answers. They're asking if there's a limitation, or what's the maximum linear velocity recommended for a hydraulic cylinder, and what is the maximum velocity you'd recommend for a pneumatic cylinder?
Well, I'm going to answer kind of generally, and when we look at Peninsula's standard seal offerings, it's in the 3 to 5 foot per second range. And there's a lot of dynamics because the longer the cylinder is, or whether or not, like you just said, air or hydraulic, and what are the configurations, taking into consideration buckling forces. Again, side load seems to be a hot topic today also. So really within the application, if we look at just the seal wear characteristics, we're looking at 3 foot to 5 foot, maybe closer to 3 foot. We also have a wide variety of solutions to different applications where we've gotten up to 10 foot per second with some good success, and on longer cylinders too. And also when you're looking at, something like that and just discussing coefficient of friction, we have a lot of solutions on the wear band types of materials and the configurations for the distance between wear bands, say if there's a stop tube application to take care of some of the buckling loads. So the short answer is 3 foot per second, and then also if you have an application where it needs to be faster, there are solutions that we can apply for that.
Okay, very good. Another question came in relating to what we were just talking about before about the chrome plating. Question is, in the case of chrome plating inside the cylinder or on the rod, what's the allowable thickness? What's the thickest you can go with a chrome plating?
Well, the industries that have cropped up that are plating for hydraulic cylinder manufacturers, it's in the range of the 3 to 5 10,000ths of an inch. So less than half of a thousandth of an inch is what's standard for the hard chrome plating. When we need to get thicker, it's a different type of plating process where it has to be pretty well engineered. It just can't be chrome plated to a thickness. In some cases, it's up to 20 thousandths of an inch thick in different types of application. But the standard product line for NFPA and ISO type cylinders is 3 to 5 10,000ths of an inch of hard chrome plating.
Well, and I believe the question is, how thick can you go? And basically, there's a substrate. If you get into we've seen as much as 20 thousandths. So
Right.
hopefully that answers your question. But it won't be 20 thousandths of chrome. It'll be a substrate underneath it.
We have vendors that claim they can go a lot thicker, but we haven't used it for that. We would usually just make a new piston rod. If we're trying to rehabilitate something, we try not to get into too thick. But 20 thousandths and even a little bit more is definitely possible.
Well, my question is, why would you want to have a thicker? Why would you want to have, say, 20 or 25 or even 30 thousandths for thickness?
Well, sometimes in the case of the steel foundries and a little bit tougher applications where there could be contamination, and that layer of the hard chromium provides that little bit of extra protection, but is cost prohibitive too. So, I mean, again, of the cross section of cylinder applications, that 3 to 5 10,000ths of hard chrome plating is more than sufficient. But where there are tougher applications and getting up to 1,000ths per size,
Or extreme wear.
it's a little bit better than the substrate of the stainless steel rod or a 1045 ferrous metal rod. So you might get the chrome, wear off if there's a little bit of a side load or misalignment pretty quickly, or if there's contamination, and can get pretty bad in a steel foundry. So having that extra chrome thickness, slight extra chrome thickness, gives you that benefit, better wear characteristics.
Okay. This next one, boy, okay, very good. This next one is pretty specific. It's regarding trunnion mounting. What are preferred support? Let me turn over. What are preferred support structure configurations? This viewer has used both split caps bolted in halves as well as oversized end caps to capture the trunnion journals. So, again, what's the preferred structure configurations for trunnion mounting?
Well, Peninsular employs a split trunnion, and we have done calculations on the strength concerning the thrust of the cylinder at the 3,000 psi. So we work within that 4-to-1 design factor of safety. Optional is a solid trunnion with just the tie rod holes, but we see some problems whether an extend or retract depending on if the tube has a step in it to capture it. So the split trunnion, in a key way, seems to be the best to us at Peninsular and has given us the longest life. Whenever we get into a tougher application, maybe it's a 3,500 psi application, or maybe it is a longer cylinder, we like to perform the FEA analysis and gauge what the actual strength of the trunnion dimensional configuration is and match it to the application. So generally speaking, most hydraulic cylinders have done their work and looked at their type of design and would claim that it works within the operating characteristics of the cylinders at 3,000 psi. But on the other hand, it could be different for an 1.5-inch bore with an 8-inch stroke as opposed to a 12-inch bore with a 60-inch stroke. And we like to get the thickness of that trunnion to give us that 4-to-1 factor of safety. And then again, you're stuck with the trunnion pintle diameters as they relate to the NFPA standards up to a certain bore size.
Okay. We're getting up to our quitting time, but we have time for one or two more. This next question is, your presentation talked about two specific types of wipers, the brass lip one and the shed seal profile. Which would be used for which type of application?
Well, let's go with the metallic scraper. And again, we're talking about industries such as steel foundries and the such. If it's a type of a contamination that could get into the cylinder and damage it, and you need to scrape it off the rod in a specific way, then the metallic scraper seems to work very well for us. The other type, the stronger urethanes, shed seal type, we've applied that in the wood, paper, pulp industries and the sawmill industries where there's just a lot of contamination in the area around the cylinder, all over the cylinder, and that seems to give a good wipe to that and keep it outside of the cylinder. So I think if you looked at the type of contamination and you were ending up with things of harder nature like sand or metal shavings or anything that would destroy that urethane type wiper, you would go to the metallic scraper. If it's just a lot of contamination and it relates to softer, maybe even non-ferrous materials, then you would go to the other type, the shed seal. We've had some pretty good success with that, and I saw a question, does it match up to some seal manufacturers? We use some of those, but we have some custom design ones that we get made that also have a pressure seal incorporated into it and some geometry to eliminate any type of pressure trap between that very good wiper and the piston rod seal itself.
Okay,
answered two questions in one.
Yeah. Yes, sir, because I was going to my next question. It would be either yes, no, or I don't know. A quick question here, because we're out of time, is the shed seal that you've been talking about, is it the same as Halite's Type 842 seal? So that's either a yes, no, or I don't know.
It's a no because it's not the exact same geometry. It's got a little bit added features with the pressure seal and the anti-pressure trap engineering into it.
Okay, very good. Well, that's all the time we have time for today. We do have several questions that were posed that we did not have time to answer. So any questions answered during this live will be in the archived event, and those that were not answered, they're going to be answered subsequently. So when this webcast gets archived on the Hydraulics and Pneumatics website in probably next week, you'll be able to see these other questions and what the answers to them. So thank you very much for attending, and we hope you all got a lot of great information from this webinar. Have a great day and a good weekend coming up.